Hello everyone, welcome to my channel, and this is KenMath, and in this video we're going to talk about calculus. If you are new to my channel, please don't forget to subscribe and hit the notification bell. And if you have got questions after the end of this video, please don't forget to comment down below. So we are talking about calculus, and in the calculus we are talking about what we call differentiation. So differentiation, if y is equal to the function of x, then the function prime of x, or the dy over dx is called the differential coefficient, or it is called the function, the gradient function, or it is called the derivative. That's what it is called with respect to x. So if they say with respect to x, for example, we have got a graph like this, and this graph, it has got a line which shows like that, or it has got a curve. Let me draw nicely a curve. So if it has got a curve like that, so it has got a curve which is going like that. So you find that the y measures the rate which is increasing, the rate of the y, it is increasing with respect to this x, because this is x-axis and this is y-axis. That's what usually happens. So let's go to the skills that we are going to talk about for you to solve the questions under what we call differentiation. Okay, so that's the dy over dx of 7, a constant 7 is equal to 0. That's how it is. And then rule number 2, or skill number 2 that you're supposed to know, is that when you find the dy over dx of a single x is equal to 1. So the dy over dx of a single x is equal to 1. So this is direct, straightforward. When you're finding the dy over dx of a single x is equal to 1, that's how it is. So it's equal to 1, that's how it is. And then there's another rule that we're going to talk about, which is rule number 3. So rule number 3, it says that when you're finding the dy over d over dx, so d over dx over, for example, we have been given a term, and then we have been given x, just like that, which is 10 to the power 1. So 2x to the power 1, when you're finding the dy over dx of that term. Let me put where there is 2, I put a, because it can be any number. So let me say x, ax there. So when you're finding the dy over dx, or d over dx of a number which is a, x to the power 1, when you're finding the dy over dx of this one, it's the same as you find this constant number which is on the beginning, which is at the beginning, it has to go in front. So we'll say, for example, it will be a, and then d over dx, a d over dx of a single x. So the single x will remain there alone. So what happens is that this a will go in front of this d over dx. So it will go in front of that d over dx. That's the a. It will go in front there. So that is the a which is in front here. And then d over dx, you're going to find the d over dx, the derivative of a single x. So the derivative of a single x, we'll say it's the same as you've been given a, and then d over dx of single x, same as d over dx of single x is 1. So we'll say multiply by 1. So which gives us a multiplied by 1, it will give us 1, a, I mean. So it will give us a, that is a. So that's the reason why they say the d over dx of a number with x, or a term which is attached to x, which is called a power of 1, it's the same as the number in front. Let's look at the example. Let's look at the example. Look at the example. So we look at the example. For example, we're finding the d over dx of, for example, 2x. So the d over dx of 2x. So the first thing that you're supposed to do is that you're supposed to take these 2 in front of the dx, so we say equals 2 open brackets, and then d will remain with dx of a single x, which will give us 2 multiplied by the d over dx of a single x is 1, so it will give us 2. So it's the same as 2. So the d over dx, or the derivative of a 2x, the power something, or a number to the power 1, it's the same as that number, which is a 2. Okay. Hope you're following. If you have got questions, please don't forget to comment, to leave them on the comment section below. If you have got questions, don't forget to leave them on the comment section below. So we go to the skill number 4. So skill number 4, it gives us that. It gives us, when you're finding the d over dx, so when you're finding the d over dx of, for example, now we have got a number. Let me put another number here. So for example, we have got a number of x to the power something apart from 1. So where n, let me say where n is not equal to 1, where n is not equal to 1, and a is not equal to 0. So there can be any number apart from 1. There can be 2, it can be to the power 3, it can be to the power 4, it can be to the power 5, and so on. This a, it can be 2, it can be 1, it can be 3, it can be 4, and so on. So apart from if a is not equal to 1, or n is not equal to a is not equal to 0, and n is not equal to 1. That's what we're talking about. So what is this d is going to give us? So it gives us a n x, it gives us a n x, and then to that power, which is n, we take out 1. That's how it is. So we'll drop this a n, the power, we multiply with the coefficient, which is a, and then from this power we take away 1. That's what they were saying. Okay, so what is the example for this one? The example for that one is x d over dx, d over dx. Or for example, we have got 2x to the power 4, 2x to the power 4. So how can we differentiate that one? So we say 2 will be multiplied by 4, like that, and then x, and then 4 take away 1. That's what it means. So n multiplied by the power multiplied by the coefficient, and then to this power we take away 1. So 2x multiplied to the power 4, 4 multiplied by 2, 4 multiplied by 2 x, and then from this 4 take away 1. So what are we going to have? We're going to have 2 multiplied by 4, it gives us 8. So it gives us 8x, and then 4 take away 1, it gives us a 3. So that is the final answer. So that's how we find. So that is rule number 4. That's what. Okay, we go to the next example, or the next skill that we're going to talk about. We go to the next skill. So the next skill is talking about when you have a d over dx. So d over dx. So we're finding the derivative of, for example, we have got 1, then over x to the power something. So x to the power any power here, and then we're finding something like that as a fraction from, and then x has got a power something. So I've already said that where n is not equal to 0 is where n is not equal to 0. That's what I've said. So what does this one give us? So this one gives us this n, we are going to multiply with the power, so the numerator I mean, so it's 1 times n, and then over, from this n as the power, we add 1, so it will give us x n plus 1. That's what we are going to get when we find the derivative. Or in other terms, we're going to get, which is 1 multiplied by n, it's n, and then over, which is x n plus 1. That's what we have. So this is the other rule which is there, so that's what we usually do. Now let's talk about the example. So say d over dx of 1 over x to the power 3, and then close. So what is it going to give us? So this power multiplied by 1, so 1 multiplied by 3, that's what we have done there on top, and then x from the power we add 1, so 3 plus 1, which gives us 3 multiplied by 1, which gives us 3, and then over x, and then 3 plus 1, which gives us 4, so x over 4. So that's how they find that one. That's how they find that one. Okay, so apart from that, we're going to talk about now the combination when they have combined all these terms. So if there is a combination of all these terms, that's what we're going to talk about. So we're going to say, if you have been given differentiate with respect to x. So that's differentiate with respect to x. They have given us, we say we have 3. Let me put it quite nicely. So we have got 3x, and then 3x to the power 5v. So 3x to the power 5v plus 3x to the power 5 plus 7. So with respect to differentiating this one with respect to x. So the first thing we're going to do, we're going to come up with a different d over dx. So d over dx of 3x and then to the power 5v and then plus 7. So the other thing is that when we're talking about the rules is that when I've been given terms like this which are separated by a positive or a negative sign, then you are supposed to find the derivative of each constant number. So note that the derivative of a sum of terms, the derivative of sum of the terms of a polynomial is the sum of the derivative of each term of the separate term. So the separate term. So we separate this term. So this is a polynomial. So we separate this term, we find the derivative of this term alone, and we will find the derivative of the term alone. So we are going to say the d over dx of 3x to the power 5 close, and then plus. So we are separating each term plus the d over dx of now single 7. So these are the terms. So we have separated them, or we have separated them. So we find the dy over dx of this one. So we're going to use the rules that we have talked about already. So when you're finding the dy over dx of 3x to the power 5, same as this power multiplied by 3, and then from this power we take our 1. So we're going to get 3 multiplied by 5, and then x, and then 5, take our 1, and then plus the derivative of dy over dx of a single x, of a single number, constant number. I mean, it is constant number is equal to 0. When writing 5 multiplied by 3, it's 15. It gives us 15, and then x, and then 5 take out 1, it gives us 4, and then 0 plus 0, it is a mass that number there. So 15 x to the power 4, that is the value that we have got to find. So that's how we usually find that one. So we go to the example number 2. Other example we have been given, which is y equals 3x squared, then minus 2x plus 2. That's the other example. So when you're finding the dy over dx, so we can simply say y prime is equal to 2 multiplied by 3, which gives us 6. So multiply the power of the coefficient 6x, and then from 2 we subtract 1. So we say it gives us 2 subtract 1, which gives us 1 here, and then minus the derivative of this, which is 2x, it's the same as 2. The derivative of the constant number is 0, so 0 plus 2 is 2. So that is the answer there. So that's what we usually do. If you have got a question, you can put the question in the comment below.